This is Pedro Atencio. I am going to introduce you to my project, a study in law enforcement using deep learning technologies. So the problem that I'm trying to solve is most surveillance systems today need to be monitored by a human to detect an active possible threat of violence, because quickly identifying the presence of a firearm in a video or photos while the criminal activity is taking place could save lives. It's very hard to do that now because it requires a human to be monitoring those videos. So the aim is to develop technology to automate that identification. This technology could be incorporated into a variety of products such as the surveillance systems, law enforcement vision systems, body cams, or patrol cars. So the project methodology was to use the TensorFlow Object Detection API for the identification of the images. It is a model used extensively for detection of images. There's plenty of documentation out there. There's a website that I haven't listed in my report that talks about the API. You can see that some of the results of object detection as shown in the screen, where persons, kites, different objects are identified. There's a lot of documentation on the web on this API, and it seems to perform well. I imagine it's used in many different use cases. So for the so I'll explain a little bit about the steps involved in the project itself. So it wasn't just selecting a model or the technology. I had to select my own images to train a model. So my specific purpose of this project was for firearms. So I had to select hundreds of images of firearms to train a model. I used a pre-trained model, meaning that I used a model that was already created for a different purpose. And there are many models out there. I'm going to show here just some examples here. MobileNet SSD is one of them. Here's a page describing that. There's models that you can download from GitHub that are trained on different image data sets. And it's really easy to find them on GitHub. There's several different types of models that one can use. I used this particular one, the SSD MobileNet v1, because it was fast. So you can see the mean average precision was 21. The higher the number, the better. While the speed was relatively quick, 10 milliseconds. Compared to others, some were more precise, but they took longer. So that will be reflected in the performance of the object identification, particularly on a video. So in this project, I actually practiced with two, the SSD MobileNet v1, as well as the faster RNA Inception v2. As you can see, it's got a better precision, but much higher number of milliseconds, and performance is slower. So that was one step. After I selected the model, I began training it, and using the data that I downloaded. The training took quite a number of hours, but the process was necessary to select the optimal number of steps or epochs for training the model. After I trained it and did a brief test, I built a demonstration Jupyter notebook to show the example of the model identifying objects in 3 different sources. So I tested it using the images on a folder, a computer camera, and also a video downloaded from YouTube that I placed in a folder. And I'll show you that later. I'll describe more of the data set now. So in the data set was that I obtained hundreds of images. I divided them into training, evaluation, and test. So for training, I selected 401 images, 131 evaluation ones, and 18 test images that I use for the demonstration. And here are 3 samples. I specifically looked for images of just the handguns or handguns that are being held by people. I looked for images with different lighting, different size of handguns, different styles that I could use to train the model. As a result of the building this project, I learned quite a bit about the object detection, and in the process, some of the benefits and drawbacks of my choices. Some of them were, I achieved some benefits, such as evaluating several pre-trained models allow me to select one based on the speed and accuracy. And like I explained, I used 2 different ones, and having pre-trained models saved considerable time in having to develop a model from scratch, testing it, and may not even have yield the precision that I was expecting at all for this use case. Some of the drawbacks were that one of the models that I used was created for identifying animals. I believe primarily furry animals, and as you can imagine, it would really not suited for identifying firearms. So I basically went back and used the SSD mobile net one that I downloaded originally and focused on optimizing that one. One of the challenges was training the model itself. Training the model took considerable time, as much as 10 hours on my laptop that had a GPU. And one of the challenges that I also had was setting up the TensorFlow software, the API, to work on my laptop. And because of the amount of time that it took to set it up, I did not want to do the same on AWS, which would have probably given me a better performance using a GPU with higher performance. But I stayed away from that because of the time that it took just to set up the API. The results were pretty good. I tested with 2 models, as I explained. One was faster, but lower accuracy, and then the other one was higher accuracy but slower. So I focused on the SSD Mobile Net V1 Coco, and as I explained earlier, I ran it for a long period of time and determined that what was the optimal number of epochs, which was about 7,500 actually. And then you can see the results there, where the accuracy keeps on increasing. When I actually ran longer, that curve started dipping and the accuracy started dropping. So I knew that the optimal number was about 7,500. So I retrained again with the 7,500, and I achieved some of the much better performance. Here's just a sample of one of the images. I'll show you now in TensorBoard what that looked like. So in TensorBoard, this is my last run that I did with the model. And as you can see here, the precision using the 7500 steps kept on increasing. I'm going to go down and I'll show you the loss. So the loss was continually decreasing, and for until about 7500, and there too it began increasing with more steps. So this was a retraining, and it performed similarly up to that same number of steps that I have seen before. Tensor board also shows the images as the evaluation takes place, and the images here that are shown are from the evaluation set. The one on the right is the one that I had labeled manually, because labeling is something that's required for this API. So this is part of the a large number of evaluation images that I had. And as the model progress training and evaluation, you can see the progress. And sometimes none of these are identified, none of these firearms are identified, and sometimes they are, so it goes back and forth. Here, with the 7500 steps, most of them were identified. There are some false positives, so you can see that the models chose to select this person's head, the hat, and the hearing protection as a handgun, which is incorrect. Some of the other images, in observing the training, I noticed that this particular one hardly ever, if at any time, selected the handgun. For some reason, it hardly ever did, perhaps because of the colors of the handgun compared to the wall. But eventually it did around the 7500 steps. So that was good news. Some did not, like in this one, although I did see steps where this image was identified. And this one was going back and forth and being selected, and eventually stayed selected around 7500 steps. So that's when I knew that I had a pretty good model that I could go ahead and test further. Some of the results, and I'll show you how that runs in the actual Jupyter notebook. So I created the notebook to select from 3 different sources, as I mentioned earlier. And here's some that after I ran the model in the notebook using images that were not used in training or evaluation, so it's a pure test. And as you can see, it is selecting some of the firearms correctly. However, in some of the other test images that I put it as far as test without a firearm, the model incorrectly selected some objects as handguns. So there's some improvement to be made there, but that is some of the limitations of the technology and the amount of time that I had to train it, and the number of images. So next I'm going to show you a demo of the actual model in use. So I created a Jupyter notebook that has the code necessary to pull the model, the frozen model, and into memory and actually run some tests. So as you can see, I'm importing Matplotlib to do plotting. I decided to define some constants top of the notebook. I uploaded TensorFlow. Actually, I'm going to begin running these. Actually, I'll just click through. Bring up TensorFlow. TensorFlow 1.12 is required for this API. It will not work with older versions. I always check to see if I'm using the GPU. One of the problems that I had was the wrong backend was being used to display images, so I checked it a few times. I import more of the libraries, and here's where I load the graph, the saved model that I had created and trained earlier. There are some categories or labels associated with each of the categories selected in the model. My model was only trained for one category, which is a handgun. In the future, I plan to increase the number of categories to different types of firearms, but due to lack of time, I could not add more than one. The images are loaded into NumPy arrays for processing by the model, and this code here, which I borrowed from one of the examples that I list at the top of the notebook, is to actually run the inference and determine if there's the category handgun in the image. So this code is there, and here this code I load. This is I have 3 demonstrations in this notebook. First one is to show the images coming in from a file. So I load them. I loaded about 18 of them, and I just show the first one. Then I run the model against them, and as you can see the results. So here's one image that you seen earlier. This one I have actually I can control with a detection score check whether I want to display the box or not, if it meets a criteria. So here I'm checking to see if it's got a criteria percentage higher than 90. So if it's 90% or higher, that is confident that it's a handgun, then display the box. Otherwise it won't. So as you can see, some other handguns do show, and in this particular case it's selecting the one in the holster but not the others, the other 2, and a couple of false positives there. So that was that. Then for the demonstration using the camera, I have that there available to show the object detection from my own video camera in my computer, and then there's also the model also choosing or displaying the images from an actual video that I downloaded. So I'm gonna try to see if that works. If not, then I'll have to run from the beginning. Oh, guess what? It didn't work. So I'm going to have to try from the beginning to run all my modules, and hopefully it'll work this time. So, running all the different cells prior to that. I'm going to skip the demonstration of the photos because it's easy to see and kind of boring. So I'm going to show the next one, the video downloaded from YouTube. So hopefully it'll run. Wish me luck. So it takes a few seconds to load the model, and then it'll begin. Didn't run. Or index, something didn't run. It always happens when you're doing a demo, right? And hopefully it'll work. Okay, so as you can see, it loaded the video. They already make my day. Video is very famous, and it's detecting the gun correctly. So that's the end of my video. Hope you enjoyed it.